Their rifle weighs 9 pounds. It fires 3,000 rounds per minute, and every single bullet misses. This was U.S. Army Advanced Combat Rifle Trials in the year 2019. The weapon that was supposed to replace every firearm on Earth couldn't hit what soldiers were aiming at. Not because of bad aim, because of physics nobody saw coming. The defense contractors had spent 30 years and billions perfecting the technology. The demonstrations were flawless, but when they put it in soldiers' hands, something impossible happened. The future of warfare failed a test that Civil War muskets passed, and what broke it reveals why your phone has better technology than a modern rifle. This isn't about better bullets, it's about why better stopped working. Caseless ammunition. No brass shell, no ejection. Just propellant and projectile fused into one package. Germany's Heckler & Koch built it first. G11 rifle, it looked like science fiction because it was 50 rounds stacked inside a rotating chamber. Fire rate so fast it put 3 bullets in the air before recoil kicked in. On paper, it solved everything. Lighter ammunition meant soldiers carried more firepower. No ejection meant fewer moving parts. Faster fire meant overwhelming accuracy through volume. NATO watched the demonstrations with their wallets open. Then someone fired 200 rounds in rapid succession. The rifle started cooking off, firing on its own without pulling the trigger. The propellant was igniting from barrel heat. At first, engineers thought it was solvable. Add cooling. Redesign the propellant chemistry. Space the shots. They tried everything. The rifle went from 3,000 rounds per minute to 600. Then 450. Then they realized the terrible truth. The brass shell isn't waste. It's a heat sink. Every time a conventional rifle fires, the brass case absorbs thermal energy, gets ejected, and carries the heat away. Caseless ammo had nowhere to put the heat. Every shot made the chamber hotter. After 100 rounds, the propellant inside unfired rounds started breaking down. After 200, it detonated spontaneously. The G11 could fire fast but only in short bursts with long cooling breaks. Exactly like every rifle since 1850. Germany canceled it in 2002 after 3 decades of development. But caseless ammunition had revealed something nobody wanted to admit. The problem wasn't the shell casing. The problem was chemical energy itself, which is why the military tried something that sounded insane. Railguns. Pure electromagnetic acceleration. No gunpowder, no propellant, no heat. Just electricity launching projectiles at 7 times the speed of sound. The Navy tested a prototype in 2008. It punched through steel plates like cardboard. Range 100 miles. Velocity Mach 7. The bullet didn't explode. Targasid vaporized them through kinetic energy alone. Admirals' briefings showed footage of test fires. Congressional committees approved funding. By 2017, the Navy had spent $500 million building a weapon that could strike anywhere on a battlefield from offshore ships. Then they tried to fire it more than once. The rails, the electromagnetic channels that accelerate the projectile, lasted 20 shots before fracturing at $25,000 per barrel replacement. Every shot cost more than the target. But that wasn't the real problem. The real problem was power. A single railgun shot needs 25 megajoules of energy. That's enough electricity to power 200 homes for an hour delivered in milliseconds. You can't pull that from a battery. You need capacitor banks the size of shipping containers. The Navy built them on destroyers' massive electrical systems weighing 100 tons. It worked. Then Marines asked when they could get handheld railgun rifles. The answer broke the entire concept. The energy density of the best lithium batteries, 1 megajoule per kilogram. The energy density of gunpowder, 3 megajoules per kilogram. Chemical propellants are 3 times more efficient than batteries. A soldier's rifle magazine, 30 rounds of ammunition. contains more usable energy than any battery that would fit in a backpack. The railgun wasn't replacing bullets. It was proving why bullets work, but the military had one more option. Something that didn't need ammunition at all. Directed energy weapons, lasers, no projectiles, no ammunition, logistics, just pure light that moves at light speed. Lockheed Martin's Athena system burned through truck engines in 2015. Raytheon's gear destroyed drones mid-flight. The Air Force tested laser pods on fighter jets. It looked like the revolution had finally arrived, until someone asked the obvious question, what happens when it rains? Water vapor scatters laser light. Dust diffuses the beam. Smoke makes it nearly useless. Weather conditions that don't affect bullets render lasers ineffective. But that still wasn't the fatal flaw. The fatal flaw was time. A laser needs sustained contact holding the beam on target for 3 to 7 seconds to burn through. Bullets need 0.003 seconds. In combat, those extra seconds are lifetimes. Targets move, cover appears, conditions change, and there's something else nobody wanted to acknowledge. Modern rifles, the M4, the AK-47, the platforms everyone wants to replace, they're not limited by technology, they're limited by humans. Soldiers can't aim perfectly. They can't process threats instantly. They can't handle recoil beyond certain thresholds. The weapon isn't the bottleneck. The person holding it is. So the real future isn't better guns. It's guns that compensate for human limitations. Smart optics that calculate bullet drop instantly. Recoil systems that keep sights on target. Fire control that connects to tactical networks. Tracking Point demonstrated this in 2013. A rifle scope that made anyone shoot like a sniper. Tag the target. The scope calculates range, wind, angle, squeeze the trigger. The rifle only fires when the barrel aligns perfectly. It worked flawlessly. Then they realized it cost $27,000 per rifle. Will future guns replace bullets? No. They'll make bullets smarter. The US Army is fielding the XM157 optic right now, a scope with ballistic computer, laser rangefinder, and atmospheric sensors. It doesn't change the rifle. It changes what the rifle can do in human hands. The ammunition is changing too, not by eliminating propellant, but by making projectiles programmable. The XM25 airburst round detonates at specific distances, hitting targets behind cover. The .33 at Nor Magnum extends range without increasing recoil. Future guns aren't railguns or lasers. They're conventional firearms with 21st century guidance. Because every alternative failed the same test, energy density, gunpowder stores more energy per kilogram than any battery we can build. It releases that energy in milliseconds faster than any capacitor can discharge. It works in rain, dust, heat, and cold. After 800 years of firearms evolution, we haven't found anything better. Not because we're not trying, because chemistry works. Caseless ammo cooks off. Railguns need battleship power supplies. Lasers scatter in weather. Every revolution hits the same wall. The wall of physics. The future everyone imagined, energy weapons, electric bullets, propellant-free firearms, it already happened. In laboratories, in demonstrations, in controlled tests, then combat conditions broke them all. That 9-pound rifle that missed every target, it wasn't broken, it was a nest. It showed what happens when perfect technology meets imperfect war. Sometimes the answer isn't innovation. It's recognizing why the old way still works. The future of guns isn't replacing bullets. It's accepting that some problems were already solved. Those Civil War muskets that passed the test, the future guns failed. They understood something we keep forgetting. Warfare doesn't reward the most advanced technology. It rewards the technology that works when everything else fails. And for 800 years, That's been chemical propellant in a metal tube. Maybe for the next 800, it still will be